Hello friends, welcome back to the channel. Today is day 7 of our Kubernetes series where we will discuss about replication controller and a replica set. In the previous video, we have learned what a pod is and how a pod.yaml looks like and how to spin up an application using a pod. Now imagine this. We have deployed our application in a pod, everything is running great and the users are happy, but suddenly the pod crashes. So that's a nightmare, right? So how do we prevent that? That's exactly what we are going to learn today. So about replication controller and replica set and how Kubernetes makes our application self-healing and highly available. Now what are Kubernetes controllers? We can think of controllers as the brain of Kubernetes. They constantly watch what's happening inside your cluster and make sure the actual state matches the desired state. For example, if you say, I want 3 pods running for this application, the controller will keep checking, and if one pod dies, it immediately creates another one. By this way, Kubernetes controllers provide automation, self-healing, and resilience. An example of controllers are replication controller, replica set, daemon set, deployment, stateful set. What is a replication controller? The name says it all. It controls replicas. A replica simply means a copy. So a replication controller ensures that a specified number of pod replicas are always running inside your cluster. Let's understand with an example. In our previous video, we deployed a single pod of our application. Now, if the pod crashes, our application goes down. To prevent downtime, we should always have multiple instances, pods of our application running. So if one pod fails, others continue to serve the traffic. This provides high availability. Even if you specify only one pod, replication controller makes sure that one pod is always running. If it crashes, Kubernetes automatically creates a new one. So this is called auto-healing or self-healing. Another reason why we use replication controller is load balancing and auto-scaling. Let's say one pod is serving all the users' requests. As user count increases, that single pod might get overwhelmed. So we deploy more pods to share the load. And if one node, say worker node 1 is full and we are running out of resources in the first node, Kubernetes can create new pods on the other available nodes in the cluster. That's the power of replication. Your app stays available and scales horizontally when needed. Now let's quickly see the difference between replication controller and a replica set. Replication controller was the older technology and it's now being replaced by replica set. Both replication controller and a replica set do the same job, maintain the desired number of replicas, ensure high availability, and provide self-healing. But replica set is the modern recommended approach. Replica set also introduces a powerful feature called selectors. So when a replica set starts, it checks, do any existing pod already have labels matching my selector? If yes, it takes the control of those pods. If no, it creates new pods using the pod template inside its specification. Now let's have a quick hands-on demo to create a replication controller in Kubernetes. Let's jump over to Visual Studio Code where I am maintaining the Kubernetes playlist for this Kubernetes series. Inside that, I have created a file named rs-cka-definition.yaml under the folder called day 7. Like any other Kubernetes manifest file, it has 4 sections: API version, kind, metadata, spec. Replication controller is part of the core v1 API group, so API version will be v1. Kind is replication controller. Inside metadata, we provide the name of the replication controller. Let's give it application name -rc. Labels, let's give it app as application name itself, and type as backend. The spec section describes what this replication controller should do. Here we define replicas, number of pod copies to run, and then template. the pod definition that should be replicated. We can simply copy the pod definition from our previous pod.yaml from day 6 directory, accept the API version and kind, copy everything and paste it under template. Correct the indentation. Everything should be inside template. Now here image used is my Spring Boot application, which is already available in the Docker Hub. So this is my Docker Hub repository and the image is already available. And here the exposed port is 8443 and the same port we are using inside our as a container port inside our pod. And notice now we have two metadata sections. One is for replication controller and another one is for our pod. And two spec sections. One is for replication controller, again another one is for pod. Basically, it's like a pod definition nested inside the replication controller. Next, let's push this code to GitHub so we can pull it inside our Kubernetes master node. Run the commands git add dot add files to staging area, git commit -m day 7 added replication controller definition, commit the changes, then git push to push it to GitHub. When it's done, now on your Kubernetes cluster where one master and one worker node are in ready status. So here I have already cloned my Kubernetes playlist repo. Just do git pull to fetch all the changes. Once it is done, go to day 7 directory and cat for replication controller definition.yaml. I haven't saved it, just save it and push your changes again, git add dot, git commit and then git push inside your master node, git pull. Now do cat replication controller definition.yaml. So we have our definition file ready. Now apply it using kubectl apply -f. So here -f is to provide the file name. -f replication controller definition.yaml. This will create 3 pods based on the template. In template we have defined replicas as 3. Let's verify using kubectl get replication controller desired 3, current 3, ready 3. Let's validate pods also, kubectl get pods. So you will see all the pods created by replication controller, their names start with the replication controller name. Something like seh-students RC. This is the replication controller name. This one. Since we don't have a service ready yet, to test this Spring Boot API deployed through this replication controller, let's use the port forwarding. So this is the command to use the port forwarding. Port forwarding means forward my local port 8443, means my host port, to the port inside that pod. So it will allow you to access the pod without creating a service, load balancer or node port. Since done the port forwarding, now try to access your API using curl and here use -k. So see we can see our data. Okay, so if we delete the replication controller, all pods it created will also be deleted automatically. Let's test it. Kubectl, wait, let me do kubectl get pods. Now kubectl delete replication controller and name of the replication controller. Now check kubectl get pods. no resources found, because once we deleted the replication controller, all the pods which were being created using this replication controller also deleted. Now let's discuss ReplicaSet. Alright friends, now let's move on to ReplicaSet, or RS for short. Think of it as the upgraded version of replication controller. I have already created one rs-definition.yaml file under day 7 of my Kubernetes playlist. Just like before, it follows the same 4 sections: API version, kind, metadata, spec. For ReplicaSet, the API version is app/v1 and kind is ReplicaSet. Important, if you accidentally use v1 instead of app/v1 for API version under ReplicaSet, Kubernetes will throw an error, no matches for kind ReplicaSet in version v1. So make sure it's app/v1. And here we just under the metadata, here we just give our ReplicaSet name and the labels. Name, then I'm giving the application name -rs and the 2 labels, app and type. And you can think of labels like tags. They help Kubernetes know which pods belong together. Next, the spec section, where the magic happens. This is what the ReplicaSet actually does. First, we define replicas. Suppose 3, which is basically the number of copies of our pod we want running. Then comes the template section. Inside the template, we basically copy the pod definition we used earlier. Just go to pod.yaml, copy everything except API version and the kind, and paste it under template. Correct the indentation. The key part of ReplicaSet is the selector. So under spec, mention selector, and then match labels, and app. Can give one label like app is equal to seh-students. This tells the ReplicaSet which pods to manage. Even if some pods already exist with the same label, ReplicaSet will include them. For example, suppose you already have 2 pods running with the label app seh-students. So your ReplicaSet wants 3 replicas, as we have mentioned replicas as 3. Kubernetes will only create 1 new pod, not 3. That is smart, right? So this is our full ReplicaSet definition.yaml. So we can say key difference between replication controller and ReplicaSet. Replication controller does not require a selector, but ReplicaSet requires a selector with match labels. That selector is what helps ReplicaSet know which pod it should manage. Now add this ReplicaSet definition.yaml file to your GitHub. Git commit -m ReplicaSet definition file added, and then git push. Once it is done, go to your master machine, and here do git pull. Do cat ReplicaSet definition.yaml. So here the updated definition is available. To apply to create the ReplicaSet, use kubectl apply or kubectl create -f is for file ReplicaSet definition.yaml. So it will create a ReplicaSet. Do kubectl get ReplicaSet to validate. So ReplicaSet is created with desired current and ready count as 3. If we do kubectl get pods, we have 3 pods created with the ReplicaSet name. Now how to scale the ReplicaSet to 5 replicas? So there are multiple ways. One is to update the ReplicaSet definition file itself. So do vi replicaset definition.yaml, and here change the replicas to 5, save it and apply kubectl apply -f replicaset definition.yaml. Once you do kubectl get replicaset, so it is showing the count as 5, and if you do kubectl get pods, and now 5 pods are running. And another, we have replicaset, we have kubectl scale command, so we can use kubectl scale -replicas. Suppose I want to set to 6 and replica set and the name of replica set. If we do kubectl get replica set, now count is 6. If we do get pods, so 6 pods are running. So the commands which we have learned today are to create replication controller or replica set. We have kubectl apply -f, then file name. To list the replication controllers, kubectl get rc. To list replica set, kubectl get replica set or rs. To list pod, kubectl get pods or kubectl get po. To delete replica set or replication controller, kubectl delete replication controller or and its name, or replica set its name. Scale manually, you can do kubectl scale -replicas. You can provide the replicas, how many replicas you want to create, and then replica set and then replica set name. How does kubectl replace command works? For example, inside your replica set definition.yaml, you have replaced the replicas to 9, and then you will run kubectl replace -f, then file name replicaset definition.yaml. It's replaced. If you do kubectl get replica set, so now it will show you 9. And up, let's take a CKA-style exam question. So we need to create a replica set name web app replica set. Image should be nginx. Replica should be 5. There is already a pod running in our cluster of label app is equal to web app. Make sure total 5 pods are running with label app is equal to web app. Means one pod is already running, and with by using this replica set, 4 new pods should be created. Let's first create that one existing pod manually. On our Kubernetes cluster, run the command kubectl run, give pod name as web app, -image is equal to nginx, because image should be nginx, and labels is equal to app is equal to web app, and we can give restart is equal to always, and --port is equal to 80, although it's not mandatory. Okay, let me correct the spelling of labels. Okay, pod being created to kubectl get pods. So we have, okay, one pod is getting created. So this creates a pod with the image nginx, labels app is equal to web app, and restart policy always. So this simulates the existing pod mentioned in the exam question. Next step, create a replica set YAML file. Now we will create a manifest file for our replica set. Let's open Visual Studio Code and create a file named rs-cka-definition.yaml. So we follow the usual 4-section structure. API version for replica set, it should be app/v1, kind replica set, metadata. So here name should be web app replica set. Copy this and paste it here. No need to provide labels for replica set here. And under spec section, as mentioned in the question, replicas should be 5, so give replicas as 5 colon 5. And under template, copy the pod template, and we will change the image name and all from and all later. So correct the indentation. So under template, we have metadata, then labels. Label should be app is equal to web app, as mentioned in the question. We can remove the another label. And the spec container name can given as nginx, and image should be nginx. Container port can be given as 80. And we left with one section, that is selector. Can give selector here, and match labels app is equal to web app. Okay, so here replicas 5, selector match labels app is equal to web app. Template defines how new pod will look, in this case using nginx image. So next step is to version control, push it to GitHub. It's always a good practice to maintain your manifest in Git repository. That way every change is versioned and reusable later. Let's push it to GitHub. Do git add dot git commit -m ReplicaSet CKA-definition file created, and git push. So once it is done, on your Kubernetes cluster, do git pull. File being pulled, do cat rs-cka-definition. Okay, so this is our definition. Now apply kubectl, apply -f ReplicaSet created. So to verify what happened, kubectl get ReplicaSet 5 desired, 5 current, ready 1, so others are also coming up. Then kubectl get pods. So 1 2 3 4 pods being created using ReplicaSet, and one existing pod was there which was already having that app is equal to web app label. I can show you kubectl get pods -l app is equal to web -app. So all the 5 pods having the label app is equal to web app. So that this is way, so you will notice one pod has already running, and the ReplicaSet created 4 new pods to make a total of 5. That's exactly what the question asked for. Quick recap, we created one existing pod with label app is equal to web app, then defined ReplicaSet with replicas 5 and the same label. The ReplicaSet detected the existing pod and only created 4 new pods. So total pods with that label are 5 we have. Okay. And that's how you solve the this kind of question in the CKA exam. Clean, simple and correct. That's all for today's session. If you like it, please subscribe the channel.